Let's say the initial problem, I'm going to go ahead and rewrite that back in. What if it was 5x minus 6? We'll put absolute values around that. Plus 9 equals, we'll put 0 on that side. What you're going to notice is in this problem, the absolute value isn't by itself. And in the other problems, they were, if you go back and check your notes. So before you can even start doing each case, you've got to get these absolute values by themselves. In this case, the plus 9 is the thing that's in our way, or not on the right side. So we're going to go ahead and get rid of that by subtracting it. We're doing the opposite. So I'm going to get rid of this a and b, and I'll rewrite it here in a second. That whole thing should give us the absolute value of 5x minus 6 equals 0 minus 9 should give you negative 9. I forgot my other absolute value bar there. So in this case, our absolute value, or what's inside it, is our a, and this negative 9 is going to be our b. Now before we went through case 1 and case 2, and we found out there were two solutions that we could plug back into this thing. For this particular problem, we've got another issue to deal with. And that's that we know absolute values always turn whatever's inside it into a positive number. So we know this side, or this a, is going to wind up being positive. But when you look at b, that tells us it's going to be a negative number. That's just not possible. So once you move everything and get the absolute value by itself, if that tends to equal a negative number, that's going to be a hint that you don't have to go on anymore. That that's not possible, and in this case you're going to say there's no solution. Another way to write that besides x, say no solution. Some people like to write x equals empty set, which tells you there's no answers within the set of solutions. So you can either draw that circle with the line through it, or just say x has no solution, x equals no solution. Myself, or whoever your teacher is, should understand what that means. Okay. So let's try a couple more problems, kind of along those lines. We'll say, what if you had 4 times the absolute value of w minus 7? And for this one, we'll say, what if it equals 36? Again, notice that the absolute value is not by itself. The 4 is attached to it. So we want to get rid of that and get everything we can that's not inside that absolute value to the other side. In this case, two things next to each other means multiplication. If we're doing opposites, we're going to divide by 4, divide by 4. These will cancel, leaving us with just that w minus 7 inside the absolute value. And 36 divided by 4 should give you a positive 9. So notice that this absolute value says it should be a positive number. That's true, so we're going to go on to this case 1, case 2. In case 1, that should tell us w minus 7 is our a, and that's going to equal a positive b, or in this case a positive 9. In case 2, again we're going to do w minus 7 for the a. And that's going to equal, notice there's a negative in front of whatever number should be there, so this will be a negative 9. Again, we're going to solve for w, so we'll say plus 7 plus 7 should leave us with w equals 9 plus 7 is 16. Over here we have w minus 7 equals negative 9. We'll add 7 to both sides. And this should leave you with w equals negative 9 plus 7 is negative 2. So we've got two possible solutions. We want to check those and see if both of them work. So let's say back at our original problem we had w minus 7 equals 9. Instead of this w, we're going to go ahead and put a 16. If we solve this out, that'll give us the absolute value. 16 minus 7 should be 9. The absolute value of 9 is 9. Turns out there's one of our solutions. So we'll say x could equal 9. Over here we rewrite the original problem. W w minus 7 inside the absolute value bars equals 9. Instead of the w, remember we're going to put the negative 2 as our possible solution. Negative 2 minus 7 gives us the absolute value of negative 9 equals 9. We know the absolute value of anything inside there has to be a positive number. And again, there's another solution. Notice that, so we'll say x could be positive 9. It could also be negative 2. And I imagine you're somewhat confused because I wrote an x here. That was my fault. This is actually a w in this problem. So w could be 9 or w could be negative 2. Boy, all kinds of mistakes here. Actually, 9 was our final solution that we checked for. W was actually 16. So again, I'm sorry, w could be 16 or w could be negative 2. And it's whatever you solve for initially before you went on to check those. Alright, let's try another problem here, just for practice. Let's say we had the absolute value of 6x plus 2. And you get plus 4 equals 0. Notice the absolute value is not by itself yet. So we want to go ahead and move this 4 over. We'll subtract 4 from both sides, see what's left over. That should give you the absolute value of 6x plus 2 equals 0 minus 4 should be negative 4. So you ask yourself, should I go on to this case 1, case 2? You don't want to do any more work than you have to. What do you notice here? Again, the absolute value equals, this says it equals a negative number. Again, we know that that can't be true. It's got to be a positive number, whatever that's going to be. So in this case, we don't have to go on. We'll just say empty set. There's no solutions for this problem. Try a couple more here. What if you had the absolute value of h minus 5? And we'll say equals 3h minus 7. For this problem, it'll seem kind of confusing because you have the extra letter over there on the right side. All you have to think about is getting the absolute value by itself and everything else that's not inside there to the opposite side. And we've already got that in this case. I'll go ahead and write the AB right below here again. Notice everything inside here is always A, and everything that's on this side is always B. So for case 1, we're going to say h minus 5 equals, and the B is going to be everything that's there, 3h minus 7. For case 2, we have A again, which is h minus 5 equals, notice there's a negative B this time. Because it has that negative there, and there's so many things here, I like to go ahead and put that in parentheses. So I know that that negative means all of this has to be negative. And the reason that's important is because this is going to be negative as well as this being negative. And if you think about it as being a negative and not seeing any number there, we said in a previous lesson, that just means there's an imaginary 1. That's like saying there's a negative 1 out front. And this just turns into a distribution problem where you send that inside. So since this is negative, that's actually going to be h minus 5 equals negative 3h. And a negative times a negative gives you positive 7. Alright, now we can go ahead and solve case 1 and case 2 here. We want h by itself, so we're going to add 5 to both sides. That should give you h equals 3h minus 2. Notice we're not finished because we actually want the h's all on one side. If we go ahead and move the h over here, and we're thinking opposites, right now this is a positive 3h, so we're going to subtract 3h from both sides, see what's left over, and 1h minus 3h is negative 2h. 3h minus 3h, those go away, leaving you with just negative 2. The h still isn't by itself. The last step is divide. Remember, when two things are next to each other, it means multiplication. If you're thinking opposites, we just want to divide by whatever's still connected to it. So we'll divide by negative 2. These will cancel, leaving you with h equals negative 2 divided by negative 2 is just going to be positive 1. So one of our solutions is going to be positive 1. We'll double check that in a second. Over here we're going to add 5, see what's left over. That'll leave you with h equals negative 3h. 7 plus 5 is positive 12. The h's still aren't by themselves. We want them over here on this side. Thinking opposites, we'll add 3h to both sides. h plus 3h is 4h equals positive 12. Dividing is your last step, so we'll divide by 4 since it's connected to the h. This should give you h equals 12 divided by 4 is 3. So right now these are our two possible h values. I'm going to go ahead and erase some of this just so we can plug that back in and you can see it on the camera. Make sure you've got all of this so far. If not, rewind the tape and make sure it's in your notes. I'm going to go ahead and erase it and put these values back up here. So we said for case 1, h could possibly be 1. And in case 2, after solving all that out, h could be 3. So let's verify that and see that both of those work.